All right, we're in section 9.1 where we're going to find square roots and compare real numbers. Uh, so anytime you use the term square roots, you are trying to find the value that is the square of the number that is shown. So, for example, you have the number 16. 16 can also be written as 4 squared. So, the square root of 16 would be 4. The reason why it would be 4 is because if you were to square 4, you would get a result of 16. Another thing that you can keep in mind is it also works with the negative number. So if you look here, I have the negative 4, and if you were to square that, because if you were to expand negative 4, it would just be negative 4 times negative 4, and two negatives multiplied together make it a positive. That's an also a result of 16. So in this example that they show here, both 4 and negative 4 are square roots of 16. All right, to be able to identify what a square root looks like, this is what it looks like. You can see that on your calculator. Uh, it's usually a second icon most of the times on calculator. Sometimes it can be showed up as a square root, looks something like this. But yeah, if you were to type that in and then put the value, like in this case, you would put it in as 16, you would get a result of 4. But one of the things that we have to keep in mind is there are instances where if we have a positive value, as so for example here we have 9, both 9 could be the result of both positive and negative 3, which we have here. Anytime that you have a square root of 0, the result is 0. But the one thing that we do have to keep in mind is if we ever have a negative value on the inside of the square root, we have no real solution. There's no such thing as a negative square root. So please keep that in mind. All right, so looking at these values here, or these examples, first off we have the square root, so we have plus or minus the square root of 100. So since we have uh, the square root already written in the value, we can just write it as the signs that are given to us. So for A, it's plus or minus, B, it's just positive, C, it's negative, D, it's also positive, just like B. So I go over here, I also write in the plus or minus from there, and then I type in the square root of 100. The square root of 100 in my calculator is a value of 10. So my result of the plus or minus the square root of 100 would be plus or minus 10. For B, square root of 54, since it's positive and they already wrote the square root in, I just write in the positive value, and square root of 64 is 8. For C, I got the negative on the outside. That's not a no solution. Remember that, because it's on the outside of the square root, not on the inside. And the square root of 400 is going to be 20, so it is negative 20. All right, the last one here, you have a value on the outside of the square root, you have a value on the inside of the square root. So it's going to look like this. So since 3 is positive, I write 3, and it's going to be multiplied by the square root of 64, which we know it's square root of 64 is 4, and then 3 times 4 is 12. Okay? And so we'll try some more, similar to what we did in those previous examples. So we have plus or minus, we write plus or minus here. Square root of 25 is just 5, so it's plus or minus 5. 3 times by the square root of 81. So we got the 3 here. That gets multiplied by the square root of 81. Since it's positive, it's going to be 9. And 3 times 9 is 27. Over here, I got 5. That gets multiplied by the square root of 0. That's just 0. Well, 5 times 0 is 0. And then for D, now we have the square root on the inside, or I'm sorry, the negative value on the inside. Anytime you have that, we have no solution. Okay, now in these examples here, it says approximating square root. It says, what if the number you are taking the square root of isn't a perfect square? All right, so we've looked at different perfect squares, like 1's a perfect square, 4 is a perfect square, 9, 16, 25, 36, going on and on and on. Now they want us to approximate it. There are two different ways that they're going to ask us to approximate in this particular lesson. The first thing they want us to do is round it to the nearest integer. Okay, so rounding it to the nearest integer, that means it's the nice clean values. So like, -3, -2, -1, 0, 1, 2, 3, go on to here and go on to there. So that's what they're looking at. They're looking at the integers. They're not looking at anything with decimal points. They're not looking at anything with fractions. We're just looking at the nice clean values that are both positive and negative numbers. So here is what you can do. Uh, if you don't use your calculator, you can look at the perfect square values that are in between the number 32. So the values that are perfect square that are between 32 are 36 and 25. The reason for that, if I took the square root of this would be 5. If I took the square root of this would be 6. So that means that 32 is going to fall between 5 and 6. So the question remains is 32 closer to 36 or is it closer to 25? If you look here, looks like it's 4 away. When I look here, it's what, 7 away. So it's closer to 6. So I'm going to say to approximate to the nearest integer, I would say that my result is 6. All right, sometimes it's a little bit more challenging here. Like I got the square root of 265. You may not be able to easily identify um, values that are already perfect squares, but this is approximately, and since I got the negative there, negative 16.2788. All right, but they want to the nearest integer since it's 0.2. Negative 16 is my approximation to the nearest integer. So again, still approximating to the nearest integer, taking the square root of 20. I got this one is approximately 17.89, and since the 8 can be rounded up, so I can round this up to 18. Okay, so this is how you kind of can punch it into your calculator to help you evaluate square roots. Another way of approximating is they want you to round it to a decimal, and in this case, they want us to round to the nearest tenth, so just one decimal place. So I go over here, I got this -2. That gets multiplied by the square root of 57, and the square root of 57, this is just 7.5. I'll just go 5.4 for right now. And so 7.54 times it by -2 is negative 15.08, but because they want to the nearest tenth, we'll just say it's negative 15.1 approximately. So I go over here. I got 7 on the outside. I got the square root of 169. That's 13. There's no need to round, so 13 times 7 is 91. Another thing they're going to ask us to do is evaluate. So done this before where we have numerical values represent variables, and then we go about substituting them in and then going about solving them. So for example A, I got the square root of b squared minus a squared. When I insert the values, it's going to be 4 squared minus 12. So square roots kind of fall into that grouping symbols notion. So inside the grouping symbol, got to take care of the exponents. 4 squared is 16, and it's going to be subtracted by 12. This is turning into 16 minus 12, which is 4. Square root of 4 is 2. We look at B, I got 3 times it by the square root of A, which in this case is 12, times it by B, which is 4, and that's going to be added to 1. All right, inside the square root, which is like a grouping symbol, 12 times 4 is 48. And I add 1. 3 times by the square root of 48 plus 1, which is 49. And here I get 3 times by the square root of 49, which is 7. And that leaves me with the result of 21. All right, so now it says solving an equation using square roots. All right, so just like uh, addition and subtraction, multiplication and division, square roots and squares are inverse operations of each other. You can undo squaring of a variable by taking the square root of both sides. Okay, so this is where we do the same algebra. We add 3 to both sides because I want to isolate our variable. So that gets canceled. So now I have 18 equals 2h squared. All right, now I divide everything by 2. So now I got 9 equals h squared. So now to get rid of the square, the inverse operation that the directions were telling us is we can take the square root of both sides. So the square root of h squared is just h. And now, since we physically wrote down the square root, we have to take into account both the positive and negative value of the square root of 9, which is 3. Okay? The reason why we can do that is if we plugged it back into the original equation, both 3 and negative 3 would in fact work. If we go to example B, in this case here, we divide 0.5 to both sides, which gives us, looks like 324 over here, and I get t squared. Take the square root of 324. I get t on this side, and remember, since we wrote it, it's plus or minus 18. Okay, and that is being able to use square roots with approximations, being able to use square roots in equations, and that's about it. Hope this helps. Till next time.